Hi guys, welcome back to day 3 of our review week. Today we're going to be talking about simplifying radicals, something you should have learned last year. Radicals are like square roots, but it doesn't have to be just a square root. It could be a cube root and such. So here's an example of two radicals that I'm going to simplify. So before we get started on that, to make simplifying radicals as quick and easy as possible, you want to know all of your perfect squares. These numbers on the right, these are your perfect squares. Okay, well, you probably already know all the way up to 12 squared, which is 144, but it's very, very convenient to know these last three, and it's not too hard also. These three come up so often that it's just easier and quicker for you if you memorize them. And it's not too bad because notice 3 squared would end in a 9, 4 squared is 16, it ends in a 6, and 5 squared is 25, ends in 25. So I think those are easy to add to your memory bank. Okay, so to the first example, the square root of 90. I might teach this a little bit different than you learned it, but the concept is still the same. What I do is I just say, find two numbers that multiply to 90, but one of them is a perfect square. So find two numbers that multiply to 90, but one of them is on this list over here. Okay, so 9 times 10 would work because 9 is a perfect square. Then, if you can take the square root of it, you take the square root of it and it comes out of the radical. The square root of 9 is 3, so it comes out of the radical. The 10 can't be broken down any further using any perfect squares over here, so that's done. It's just 3 root 10. That's my final answer. Okay? This is called simplified radical form because underneath the radical is a 10, and I can find numbers that multiply to 10, like 2 times 5, but I can't take the square root of any of them, so you leave it like that. Now, by the way, what does it mean? The original problem, the square root of 90, if you put that in your calculator as a decimal, it's like 9.4, 9.5. Well, here, if you put this in your calculator, 3 times the square root of 10, it's also 9.4, 9.5. This is just considered simplified radical form. Why do we do it? Well, because you can do more stuff with it later on. All right, next example, 72. Well, you might think 9 times 8, okay? I'm going to show you in a minute, though, that that's not your best choice. It works, but it'll take you longer. 9 times 8, yes, that's 72, you're right. And yes, you're right that 9 is also a perfect square. And the square root of 9 is 3. The reason is this is not the best option, though, is 8 can still be broken down using a perfect square. It's 4 times 2. So we got to go a step further. Bring down the 3, but break up the 8 into 4 and 2. 4 times 2. Now you just do another step. The square root of 4 is 2. It comes out by this 3 over here. And now the final answer is 6 root 2. Okay? And now it is completely simplified. Now if you look at that 6 and you consider putting it back underneath the radical, that gives you a hint at the better choice or quicker choice of numbers for the original problem. Let's go back to the square root of 72 at the top again. When you're considering this list of perfect squares here on the right, you want to, if possible, use the highest possible perfect square, and 36 times 2 is better than 9 times 8, which is what you would get if you put the 6 back underneath there. So if you had thought of 36 times 2, this job would have been a little bit quicker because the square root of 36 is 6, and then 2 doesn't get broken down any further, and it's a little quicker. But no big deal. Just always look underneath the radical and ask yourself, could I break that down further using these perfect squares? Okay, let's see if I have another example. I don't really remember. Aha! 2 more examples. If you want to, you can try them on your own, or you can watch me. Hit pause if you want to try them on your own. Okay, the square root of 50. This is similar to that one I just showed you where there's more than one way to do it, but there's really only one right way to do this one. You might think 5 times 10 for 50. Oops, sorry, technical difficulties. Let me go back to it. I lost it. I'll do that a few times. I'm kind of slow. All right, you might think 5 times 10 for 50, but can you take the square root of 5? No. Can you take the square root of 10? Nope. So that doesn't work. So instead of 5 times 10, you have to use a number on this list. And if it ends in a 0 or a 5, 25 or 100, those are your go-tos. So think of quarters. So 50 is really 25 times 2. Think of quarters. Okay? And then I can take the square root of 25. The square root of 25 is 5, so I get 5 root 2. Done. Okay? 80, same thing. I can use 8 and 10, but I can't take the square root of 8 or 10. So if this is an 80, I'm going to start at 81 and work my way backwards perhaps and look for a number that will multiply or divide into 80. Does 25 work? I don't think so. How about 16? Okay, the quickest way to do this problem is it 16 times 5? I think so. Sure, 16 will work. I don't know, I wrote that kind of funny. All right, so that's how you have to break that one down. You don't need to consider every possible number in the world that multiplies to get to 80. You really only need to consider this list of numbers. So you don't need to try everything. Just try the numbers that matter. All right, square root of 16 is 4. So you're done. 4 root 5. Call it a day. Okay? Now I'm going to show you one more way that you could have done that last problem. So 4 root 5, that was our answer. And here it is one more time. Okay? If you're not sure how to get what numbers multiply together to give you 80, and all you can think of is 8 times 10. Okay? If that happens, 8 times 10, that didn't help me. Well, break those two numbers down again. 4 times 2 and 2 times 5. This might give you a hint. I can already do the square root of 4. This is another 4. 4 times 4 is 16. There's lots of ways to think of it, but in the end, this is the same as 16 times 5, and that's why the answer is 4 root 5. Just as a fallback to not coming up with the 16. All right, I hope you remember how to do this. I hope it's not too tough. Good luck on your worksheet, and I look forward to seeing your faces soon. Bye.